Hey guys, welcome back. We're doing some dynamics, having some fun with that. Here we have a projectile example. So a person on the field throws the ball horizontally at the wall at 15 meters per second. There's a coefficient of restitution between the ball and the wall at impact of 0.9. There is no friction in the system. So they throw the ball against the wall, then it bounces off, goes up over their head, and we're asked to find D. So let's get to it. I chose this problem not because it's particularly difficult, but so that we can look at some oblique mechanics and get our heads around these various coordinate frames. So let's start with the free body diagram of the impact. Right, so we got our ball, and it is making contact with this line, and it is coming from this direction. Right, so this we'll just call this V naught, and as we know from the lecture, this is the tangential direction. And this, so if I can do a good job here, this is the normal direction. So we could choose either. Let's go here. Okay, so at impact, I guess that line is a little bit high, that's all right. So there is a normal and a tangential component to V naught. So the normal is going to go this direction. So we can call this V naught normal, and the tangential is going to go this direction, and V naught tangential. And this 60 degrees here is this 60 degrees here, right? Which means that this is 30 degrees. So what we can say is that as we're figuring this out, we'll say that, we'll put it up here, we'll say V naught tangential is, and that looks like I'm multiplying it there, so V naught T, that is V naught times the cosine of 60, right? So let's get a number for that. So 15 times the cosine of 60 degrees is 7.5. Okay, and that's going to be meters per second. And V naught N is going to be 15 times the cosine of 30 degrees. So that is 12.99. And again, meters per second. So what we know is that the V naught T is equal to, and I guess let's put that up here. We'll say V naught T prime is equal to V naught T, which is 7.5 meters per second. Okay, and unfortunately, the normal direction, not quite so straightforward, but that's all right. What do we need? We need one of these. Well, let's use this one first. So we'll say V naught A, or V prime of ball minus V prime of the wall is equal to E times V prime of the wall minus V prime of the ball, right? And the wall isn't going anywhere. Okay, so V prime of the ball is E, which is 0.9 times V prime of B, and this, by the way, these are in the normal directions. I just said that that's not prime. I'm sorry, guys. That is V naught n, right? Because these are specific. So this is V n, okay, and that is 12.99. We need the negative of that. So V prime B is going to be equal to 0.9. That is 11.6913. It's going to be meters per second. Okay, and so we have the values coming back out, right? So this is, sorry, this is negative. We've defined our direction. So now we need to convert these back to XY coordinates, right? So our V naught, do it one at a time. So V naught T, or I guess V, this doesn't make sense. V naught prime, yeah, that's fine. V prime T is going to have a V X and a V Y, right? And we need to do this, we'll say V T X. What's that going to be? That is going to be 7.5 is in this direction. So what we need to do is put in an X and Y coordinate. Let's put X in the same directions, right? So we'll just go in reverse. So V naught has, let's see, this is Y, this is X. Okay, so if we're going from V naught T to X, then it is cosine 60. So V naught T cosine 60. And similarly, V T Y would be the sine of 60. So prime T sine of 60. And that is 7.5. So let's see, 7.5 times the cosine of 60. I think it's just half, right? 60, this is 3.75. And then times the sine of 60. Is 6.4952. Okay, so then similarly, we'll decompose the normal. Let's get here. So V prime B should be N. Okay, it's going to have a Vn X component. So we're going from this normal direction here to X, which is here. So we would say that is cosine 30. So V naught N, or Bnx, or I'm sorry, Bn prime cosine of 30. It's going to equal something. And then Vny is going to be minus, right? Because when we're going from this direction to y, then it's like this. So it's minus the sine of 30. So minus V prime B n times the sine of 30. Okay, and what does it give us? Let's see. So we got a minus 11.6913 times the cosine of 30. That is minus 10.125 meters per second, right? Because the n direction is facing this way. So, sorry, I wrote that in the wrong place. So minus 10.125 meters per second. And then the sine is going to be 5.84565. Okay, and there, right? So now we combine the x and y components so that we get the x and y components that we need. So say Vx is going to be 3.75 minus 10.125, which makes sense because the x is, the ball is now moving in the opposite. So what does that give us? That gives us minus 6.375 meters per second. In the y direction, we add them. So this is 6.4952 plus 5.84565, and so that gives us 12.3409 meters per second, right? And does that make sense? So let's see. What we can do is a check. So we've lost a little bit of energy, but what we can do is we can check this velocity and see if this value makes sense, right? So we just say 6.375. We'll do the Pythagorean. Plus this squared, this guy there. And that gives us a, when you combine these, just as a sanity check, you get it, it's about 13.89 meters per second, right? So it makes sense. We've lost about 10%, which is what we expect since this isn't moving. So now we need to figure out where it lands. Well, we can use the y to get the time that it is in the air, and then we'll use the x to get the distance, right? So y, so what is the equation of motion in the y? So it's what s equals s naught plus v naught t. In this case, it's going to be minus 4.905 t squared, right? And s is 0, right? This is 1.2 meters, then plus, and our initial, or v naught, in this case, is 12.3409 t minus 4.905 t squared. And when we solve this for zeros, let me do that real quick. Let's say 2 plus 349 square percentage for that. And all right, gotta tell it what all of that equals. That equals 0. There we go. And So it gives us a negative value of 0.09. Well, that doesn't make any sense. This gives us t is equal to 2.6097 seconds, right? Which makes sense. Okay, so we have it moving in the negative x direction, going this fast. So overall, so s in the x direction is going to be equal to Vx times t, and that is going to be 6.375 times 2.60973. That is 16.637 meters, but we've got this little bit here. So we need to subtract that off, right? So let's call that, I'll just call it C, right? So that length at C, what is that? That is, if we draw a triangle of that, then this right here is 60. This is 1.2, and we need this, right? This distance here. So, what do we got? We can use the law of sines. Well, let's see, this is 30. Right, yeah, sure, why not? Law of sines. So the sine of 60 over 1.2 is equal to the sine of 30 over c. So c sine c is equal to 1.2 times 1/2 of, or I guess just do the sine of 30 over sine of 60. And what does that give us? 2 times that gives us 0.6928. Okay, so D is equal to this 16.637 minus this is 0.6928, and that is 15.94. Okay, and so we'll say D equals, there we go. All right, so the trick is just to do a lot of conversions, go slow, be careful with it, and I hope that was helpful. And with that, I will see you in the next video.